Hello everyone, good morning to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today in this lecture, I am going to discuss about the solutions of question bank from Module 4. In Module 4, I am taking part A, problem solving and critical thinking question from vector calculus. The name of the topic is vector differentiation. I want to discuss about vector differentiation, how we can differentiate of a function which is given in vector form. Okay. So I want to discuss detail about the solutions of question bank from module 4, and I am taking the topic part A, problem solving and critical thinking questions from vector calculus. First of all, I want to suggest two references of textbooks which are given as below. The first reference of textbook, the name of the authors are N.P. Wali and Dr. Manish Goyal, publications Lakshmi Publication Private Limited. And second one, the reference of textbook is the name of the authors are H.K. Das and Dr. Rama Verma, publication is S. Chand and Company Private Limited. So now in this lecture, I want to discuss about the solution of question bank from module 4, and I am taking the topic part A, problem solving and critical thinking questions from vector calculus, and I want to discuss here about the vector differentiation. So here I want to solve question 1 based on vector differentiation from vector calculus, and I am going to discuss part A, problem solving and critical thinking questions. So here question 1, prove that divergence r to the power n vector r equal to n into n plus 3 r to the power n. This is very most important question from given vector differentiation in vector calculus. And very important, very easy, very interesting problem. Most important problem is question 1. So solution here, prove that r to the power n vector r divergence r to the power n into vector r, this is equal to n into n plus 3 and r to the power n. This is equation 1 is given in our question paper. So now we want to prove here LHS equal to RHS. Okay. Left hand side equal to right hand side. We are taking left hand side and we are to prove right hand side. So here TLHS means taking left hand side. Taking left hand side. TLHS. So TLHS is divergence of, in bracket, r to the power n vector r. Okay. This is TLHS. I am taking TLHS. Taking left hand side. But here vector r. Vector r is xi cap plus yj cap plus zk cap. This is the vector r. Position vector r. This is the position of a point in a coordinate, three-dimensional coordinate geometry. Then vector I is radius vector. The direction of the radius vector from origin to the given point. This is general point P, X, Y, Z. P is general point in the coordinate system. on any curve. So the position of the point is x, y, z, making this point joining to origin. So OP equal to radius vector r. Vector r is xi plus yj plus zk. So now taking mod of vector r. So mod of vector r is mod of xi plus yj plus zk. So mod of vector r, this equal to under root I का कोफिशिएंट x square plus y square plus z square. So this equal to x square plus y square plus z square to the power half. Okay, to the power half. So this is known as a r vector. This is scalar vector. Scalar vector is scalar function. Scalar function r. Scalar function r. This is not vector. R is here x square plus y square plus z square and whole to the power half. Now this equation 2, this equation 2 and this equation 3. This is 3 equation and this equation is 4. Now differentiating r with respect to x. Then we get here del r over del x. Differential of r with respect to x. Then this result is 1 upon 2. Power comes before this x square plus y square plus z square whole to the power half minus 1 and into 2x. 2 is cancel. So del r over del x, this is equal to x square plus y square plus z square, this to the power minus half and into x. So this equal to x upon under root x square plus y square plus z square. So this is r. So basically dou r over dou x equal to x upon r. We get this result. This equation 5. Similarly, we can find differentiating with respect to y to r. Then we get here dou r over dou y, this equal to where r equal to x square plus y square plus z square, this to the power half. This equation number 4. This equation 4. So differentiating with respect to y here 1 upon 2 x square plus y square plus z square, this to the power half minus 1 and into 2y. So here this equal to here we write this 2 is cancel. So x square plus y square plus z square to the power minus half, half minus 1, half minus 1. So here minus half into y. So we can write dou r over dou y is equal to y upon under root x square plus y square plus z square whole to the power this. So y upon r, dou r over dou x. So this is the value of equation 6. This implied that dou r over dou y equal to y upon r. Similarly, we can find the value of dou r over dou z equal to zyr. This equation number here 5, this 6 and this 7. This equation 7. Okay. These 3 results we are using in our differentiation. What in our question TLHS here is given divergence of r to the power n into vector r. So this result is divergence means del dot. Del dot. Divergence means del dot. This is 3-dimensional differential vector operator. with here r to the power n. R to the power n is scalar and into vector r. Okay. Now here we can write this equal to divergence of r to the power n into vector r. This equal to here value of del. Here del A equal to I dou over dou x and plus j dou over dou y and plus k dou over dou z y dou over dou z. So here we write value of I cap dou over dou x plus j cap dou over dou y plus k cap dou over dou z. This is the value of del. Del is this and dot r to the power n, and here writing here xi plus yj and plus zk. Okay, here value of del equal to I cap dou over dou x plus j cap dou over dou y and plus k cap dou over dou z. This is the value of del. Del is this value. Value of del is this. So now here, so taking dot product this to this, I to I 1. So I am writing here dou over dou x of here in bracket r to the power n into x and plus dou over dou y in bracket r to the power n into y and plus dou over dou z in bracket r to the power n into z. This is equation number 8. This is 8 equation. Now differentiate, here apply product formula. Differentiation of x with respect to x, dou over dou x of x. Differential of x is 1 r to the power n constant plus x differentiation on n r to the power n minus 1 into dou r over dou x. Plus similarly here differentiation of y is 1 r to the power n is constant and plus y n r to the power n minus 1 and dou r over dou y. Plus similarly differentiation of z is 1 and r to the power n is constant plus z n r to the power n minus 1 dou r over dou z. So this is equation number 9. Now putting value of dou z over dou x, dou z over dou y, dou z over dou z, dou r, dou r over dou x, dou r over dou y and dou r over dou z from equation 5, 6, 7. From equation 5, 6 and 7. In equation 9. In equation 9. Okay. 9 is this equation. X differentiation of x is 1. R to the power n is constant. And differentiation of x r to the power n and r to the power n minus 1 dou r over dou x. Okay. Here we write this again. Here apply product formula here. Product formula means dou over r to the power n is constant. R to the power n is constant. Dou over dou x of x plus x constant. Dou over dou x of r to the power n plus r to the power n dou over dou y of y and plus y constant dou over dou f of y r to the power n constant plus here r to the power n dou over dou z of z and plus z r to the power dou over dou z of r to the power n. Okay. So now finally we write here r to the power n, r to the power n into 1 plus x and r to the power n minus 1 and dou r over dou x plus r to the power n into 1 plus y and r to the power n minus 1 and dou r over dou y plus here r to the power n into 1 and plus here z and r to the power n minus 1 dou r over dou z. This is equation 9. Okay. So now putting value of dou r over dou x, dou r over dou y and dou r over dou z from equation 5, 6, 7 in 9. Then we get here. Then we get. Now putting value of dou r over dou x, dou r over dou y, dou r over dou z from equation 5, 6 and 7 in equation 9, then we get here. Okay. Then we get here r to the power n divergence of r to the power n into vector r. This is equal to. So here we get r to the power n into plus n r to the power n minus 1 and dou r over dou x, x upon r plus r to the power n plus n r to the power n minus 1 into y upon r plus r to the power n r to the power n minus 1 into z upon r. This is equation 10. Okay. Now this equal to r to the power n, r to the power n, r to the power n. This is 3r to the power n and plus n r to the power n minus 1 upon r is common. And here is x xyr and here is x is constant. X is here x into x, here y into y, here z into z. Okay. So here is x square plus y square plus z square. This here x is in multiply this x y xyr x into x. So here we write this one x. This is r square. So now here 3r to the power n plus n r to the power n minus 1 upon r into r square. So 1 r is cancelled. So now here we get here 3 r to the power n and plus n into r to the power n minus 1 n into r. So we write here divergence of r to the power n vector r, this is equal to, here we write this result 3r to the power n and plus n into n minus 1 n into here r to the power n. Adding this result, this to the power 1, adding here plus 1. So n minus 1 plus 1 is n. Okay. So we write here this. Now r to the power n is common in bracket 3 plus n into n plus 1. N minus 1 here. 3 is r to the power n. N into r to the power n minus 1 r square. N into r to the power n. Here is r to the power n. 3r to the power n. So n is not there. R to the power n. X constant r to the power n. Here 1. So n is here. So what is answer? N minus 1 and r to the power n here. What is answer here? First, n into n plus 3. Wrong हो गया यहाँ से. This is n r to the power n. What here is r to the power n? Differential of r to the power n here. So this question is wrong here. Here is r, differential of r to the power n. This is correct, r to the power n. But differential of r to the power n here. Okay, this is correct. This is also correct. R n minus 1 and del r over del x. What is del r over del x? R is n by 2. Del r over del x. So this is 3r. R to the power n into x. 3r to the power nx. And del r over del x. R is half. X by r. So here is r and r to the power n minus 1 into r cancel, r to the power. Okay. Here is r to the power n. Not r there. Correct. This is correct. There is not r. R to the power n minus 1 क्या है? हाँ. Wrong this. This is r to the power n. Here is wrong. Here is n. Here is n and r to the power n into this result. Some mistake is there. So this result. Now r to the power n is common. So 3 plus n. और n into n plus 3 आ रहा है. n into n plus 3. n into n plus 3 r to the power n. n into n plus 3. So here divergence r to the power n. Here this. Next r is this half. So r to the power n by 2. And r to the power n minus 1 del r over del x. What del r over this is correct. X y r, y bar r, z bar r. Now here divergence r to the power n r. So r to the power n vector r. So here vector r is this. Multiply dou over dou x r to the power n into x. Differential of this. R to the power n means n by 2. So this is wrong here. This is wrong from here question. R to the power n means r means 1 by 2. X square plus y to the power 1 by 2 here. So differentiation of r and r to the power n minus 1. R to the power n, r to the power n. X and r to the power n minus 1 and dou r over dou x. And r to the power n minus 1. This is correct. Next this one here. R to the power 3 r to the power n. And r to the power n minus 1 r square. So here r is cancelled. N into n plus 3. This is answer correct. So this is n plus 3 into r to the power n. So this is RHS. Okay. LHS equal to RHS. Maybe. Next result here. Question second is prove that del r to the power n equal to this. So here solution. Prove that del r to the power n equal to n r to the power n minus 2 into vector r. So here LHS del r to the power n. This equal to del dot r to the power n. So here del dot r to the power n is x square plus y square plus z square whole to the power n by 2. Del dot is I dou over dou x plus j, this is j dou over dou y plus k dou over dou z, and into x square plus y square plus z square whole to the power n by 2. Now differentiating this, I cap del r to the power n equal to I cap dou over dou x, and here is differentiation of x square plus y square plus z square whole to the power n by 2, and plus j dou over dou y, x square plus y square plus z square whole to the power n by 2, plus k dou over dou z. Here x square plus y square plus z square whole to the power n by 2. So now this equal to here I cap, here differentiating this function, taking power n by 2 and x square plus y square plus z square whole to the power n by 2 minus 1. N by 2 minus 1 into 2x, and plus j, here again apply power n by 2 and x square plus y square plus z square whole to the power n by 2 minus 1 into 2y, and plus k, here n by 2 x square plus y square plus z square whole to the power n by 2 minus 1 into 2j. Now this equal to here 2 is cancelled, and I cap here x square plus y square and plus z square. Here n minus 2 upon 2 into x plus j cap, here n into x square plus y square plus z square whole to the power n minus 2 by 2 into 2y into 2y. Okay, so this 2 is cancelled, and plus k n into x square plus y square plus z square. Here is power n by 2, n by 2. This 2 is cancelled, not this. Here is 2y only. Here is n by 2, n by 2 2 cancel, n by 2 2 cancel, n by 2 2 cancel. Okay, so here is only y. This not 2, y. So here x square plus y square plus z square की power n minus 2 by 2 into z. Now final result is here I into del r to the power n, n vector, del r to the power n vector. What is question? R to the power n scalar, r to the power n equal to I cap here into n, and here x square plus y square plus z square की power n minus 2 by 2, and plus n into j cap x square plus y square into x here, into x plus x square plus y square plus z square to power n minus 2 by 2 into y, and plus n into k cap, and here x square plus y square plus z square whole to the power n minus 2 by 2 into k z. Okay, z. So here n is common, x square plus y square plus z square whole to the power n minus 2 y2 common, and here is ix plus yj plus zk. This function is remaining function. Okay, this is upper side problem. Okay, so now this equal to here n, and this result is x square plus y square plus z square whole to the power 1 by 2 and whole to the power n minus 2. This is vector r. This is vector r, where vector r is xi plus yj and plus zk, right? So this result is n into this result is r square whole to the power n minus 2. Okay, this is r, not r square. This is only r, n into this vector r. So now we get here n r to the power n minus 2 into vector r. Okay, this is RHS. This is RHS. So here we get this is RHS. So we get LHS equal to RHS. Proved. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.